Hello everybody, this is Mr. Kusaj, and we're going to do 4 tonight, just the first half. I already have the notes on paper, so I'm just going to point and talk about it. So the title, Graphing Sine and Cosine Function. We've been doing assignments with sine and cosine and finding values, but what does a graph of sine and cosine look like? First, let's look at the sine. I'll give you time to copy this. I suggest you leave 2 spaces here and 2 spaces here, and then go out 1, 2, 3, 4, 5, 6, 7, 8 spaces across. It's very important that you make them equal. I'm going to keep talking while you're copying. Or you can freeze it and copy it and then listen to me. It's up to you. These are the angles. So in the assignments, we know what the sine of these angles are. And these are quadrant angles. So at 0, sine of 0 is 0. Sine of 90 degrees, or pi over 2, is 1. Sine of pi is 0. Sine of 3 pi over 2, negative 1. Sine of 2 pi, full circle, right? It's got to be the same as 0. And then we start all over again, right? So we can keep going on forever that way and that way. But it doesn't go up forever or infinitely up and down, as you will see. So this is, say, the parent graph. The parent graph for sine x, okay? The cosine graph looks much the same, except, again, you can freeze and copy and then listen to me. It's up to you. It's the same as the sine wave, except if you do the values, the cosine of 0 is not 0, it's 1. The cosine of 90 is 0. The cosine of 180 or pi is negative 1. Etc., etc. Okay? So, if you look at them, this is a full circle. Starts at 1, ends at 1. And for sine, this is a full circle. Starts at 0, ends at 0. If you put them side by side, they look the same, don't they? The only real difference is how they start. Sine starts at 0, and cosine starts at 1. But as you can see, it goes up and down, up and down, up and down between 1 and negative 1. They just start off differently. Okay, so you can consider these as the parent waves. Okay, so what we're going to do now is transform them. So what if we put numbers in the front, in the middle, or the back? What does it do to the graph? Okay, so we're just going to do 2 transformations tonight, and we'll do the rest tomorrow night. Transformations. First, let's look at the amplitude. The amplitude, let me fix this a little bit. The amplitude is the stretch, or how tall from the midline it goes up and down, right? This number in the front here, the A, that is what tells us the amplitude, okay? So, for example, again, you could freeze here, but I'm going to keep talking. For example, this is y equals 2 sine x. So what this is telling me is that my amplitude should be 2, right? So from the midline to the top, or the midline to the bottom, the distance is 2. In other words, it's stretched 2. It's not the normal sine wave where it just goes up to 1. It's 2 sine x, so it's going to go up to 2 and down 2. Okay? Look at the one next to it. This one says half sine x. So the amplitude is half, which means it's going to go up to half only, not even 1, half. So the distance between the midline and the top, the midline and the bottom is half. It says so right here, right? So this number right in front of sine x or cosine x will mean amplitude. I did one for the cosine x as well. Look at this one, right? So this is y equals 2 cosine x. So remember how we start cosine at 1? Well, it's not 1, it's 2. So we start at 2 and come down to 2 and finish at 2, right? I left out the angle values because for amplitude I wanted to show you something else, but normally you would put all the angles in here, the important angles, right? But I left them out because right now I want to concentrate on amplitude. So notice how this stretches up 2. Okay. The other transformation I wanted to look at was reflection. Okay? A reflection is when you flip over the horizontal line or the horizontal axis. If we put a negative in front of the function, that's what that means. It's the typical function except flipped over. Okay? Let's see what that looks like. Again, you can freeze if you want, copy, and then listen to me, but I'm going to keep going. So by now, you should get a feel for what a typical parent graph looks like for sine x, right? Starts at 0, up to 1, back to 0, down -1, back to 0. That's sine x. But negative sine x, instead of going up from the start, it goes down from the start, right? So if you compare the two, it's just flipped, okay? That's what the negative in the front does. That's a reflection, okay? I did 2 more with the cosine wave. So 2 cosine x, we've seen that, right? Starts at 2, down to -2, up to 2, right? Starts and ends the same way. Now, what if we were to flip this, make it -2? What will it look like? Well, instead of, everything is negative. Instead of 2, -2. Instead of 0, well, 0 is 0. 0 is not negative or positive, right? Instead of -2, instead of -2, it's +2. So everything is opposite or flipped, okay? So what I want you to learn from this lesson tonight is the basic graph for sine and cosine. And usually we go just one circle, okay? But I wanted to show that it goes on by repeating. It doesn't do anything differently. So you can make as many circles as you want, it'll start repeating. So the sine starts at 0 and goes up to 1, and the cosine starts at 1 and goes down to 0, okay? That's basically the difference for sine and cosine. And then I showed you 2 transformations. The amplitude, which basically shows how far away you are from the center line. And that's this number here. So if this number is 2, that tells you that you're going to go up to 2. If this number is half, that tells you it's going to go up to half. Not just up to half, but down to half. In other words, the distance from the midline, right, to the maximum and minimum is half. Okay? And then I did one with the cosine as well. And lastly, I did a reflection really quick, right? And all that is a flip, right? As soon as you put a negative in the front, you just flip it. You go the opposite direction. Okay. So, hey, I'm only up to about 10 minutes. So I'm going to leave you with a try problem. And what I want you to do is the same thing I did, but to save space, put both of them, one dotted, one solid, put both of them on one axis, okay? So graph on the same axis. you're going to graph these two on one axis, and then you're going to graph these two functions on one axis. So that's it. That concludes the notes for this evening. I just want to say I think the notes could go a lot faster if I write them down first. That way you have the option of freezing, and if you're really fast at copying, you can get done faster. Instead of like writing them slowly and talking, I could write them beforehand and then talk about them. So I'm done under 11 minutes. Okay, see you tomorrow. Come with a lot of questions and the answers to the try problems. All right, good night.